SQL health check is like a subset of SQL, and I will talk about SQL health check at the end, and also about test case. But the core topic for the remaining of the time is SQLTXPLAIN and how we use SQLTXPLAIN to diagnose SQL statement performing poorly. Again, if you have any questions, don't wait to the end, just raise your hand, ask your question, and we go over that. So the agenda for this, what we have is, I'm going to go over some SQL tuning concepts, then I will introduce SQLTXPLAIN, I will go over installation, the main methods, how do we use the main report, health check, and test case creation and implementation. So some concepts about SQL tuning. Okay, what is SQL tuning? Is this an art, science, black magic, a little bit of everything? It all depends who you ask, right? I remember when I started looking at SQL tuning issue like many years ago, to me it was like black magic. I couldn't make sense. I mean, why we have a SQL sometimes performing fine, sometimes the performance will degrade, and sometimes it will go back to normal. I couldn't understand that. To me, it was totally black magic. That's understandable. When we're trying to define what is actually SQL tuning, you may find different definitions. It all depends who you ask to. Some people will say, okay, basically what we want this SQL to run faster. That's what we want. Some people will say, you know what, this SQL was running fine a couple of weeks ago, but suddenly it's taking longer. Or we did an upgrade and my SQLs are being affected. I need to find a way to improve them back to whatever they have. To me, actually, SQL tuning is more like this. We want to improve the performance of a SQL statement in such a way that it satisfies whatever is my business requirement. For example, this morning I was looking at this email on this distribution list that was saying something about indexes, and this application has many indexes, and this person was complaining about the indexes, trying to convince development to drop the indexes. And it was going on and on and on and on, and there was a lot of people offering some advice, saying, okay, you can use index monitoring to determine if those indexes are being used. If they're not being used, you can drop them, or you can look at the history of the execution plans out of AWR. If you don't see this index, you may want to drop it. I didn't offer my opinion in that time because the thread was already quite long. But my opinion in those cases is, who cares? Who cares? I mean, if you have many indexes and nobody complains, I mean, the business doesn't complain, who cares? Only focus in those issues which are affecting your business.
So that was the performance key. Some just said there were too many indexes?
There were too many indexes. Yes, and he was trying to convince the development group to drop the indexes. The development group was saying, no, we need those indexes. And it was this polemic about, I mean, who was right? And a lot of people, they offer some advice. But to me, like, who cares? I mean, as long as it doesn't affect your business, you shouldn't go and try to fix everything that is wrong, because you will go crazy. I mean, it's right. I mean, take any SQL, well, almost any SQL can be improved. So it's very easy to be kind of a little bit obsessive. I mean, trying to fix everything that is taking long.
God just says obsessive tuning disorder.
So you know about that term, okay. Yeah, and it's true, and you see that often. I mean, it's like if you are hammering nails every day, right? After you're finished with your work, whatever you see, you're just looking at people, they look like nails. You want to hammer them. It's the same with tuning. Once you get used to tuning, you see that SQL, you immediately want to jump in and try to fix that SQL. But the question is, does it really matter? Is it affecting your business? If the answer is no, forget about that. You see people, you see DBAs, they look at AWR, they look at the top SQL and they say, oh, this SQL requires some tuning. I would say, no, not necessarily. If that SQL is affecting your business, I agree. But if it doesn't affect your business, imagine if this SQL is coming from this report that is taking 3 hours to run, and you run the report once per year. Well, who cares if the SQL is taking 3 hours, right? So that is important. Every time you are trying to think tuning, think if it is affecting your business. And another thing I want to mention here is you are trying to minimize resource utilization. Why? You also see people that say, oh, this SQL is taking a long time. Let's get Exadata. Let's say do parallel execution. Of course, if you do parallel execution, you may improve the performance of one SQL. But how is that you are affecting other people on the same server? So it's like, no, you don't tune with parallel execution. You don't do that. You tune your SQL. I mean, your SQL is business critical. You tune it serially, on a serial plan. And once the serial plan is working fine, if you still want better, then you consider parallel execution. But don't try to use parallel execution from the beginning. Is that clear? So anyway, that is the way I see SQL tuning today. But, so it went from black magic to basically focus on the business. Don't overdo this, and always think whatever method you use for your SQL, think that there are other people using the same server. So don't go with parallel execution like crazy. So another concept here, what is query optimization? Query optimization is not the same as SQL tuning. SQL tuning is our work. Query optimization is part of the CDO. The cost-based optimizer is doing the optimization of the SQL, which is not the same. We have to collaborate. I mean, we help the optimizer, and if the optimizer is like a person. If you are nice to the optimizer is going to be nice to you. Is that right? I mean, if you are mean to the optimizer, guess what? The optimizer is going to be mean. Okay? So just think that way. That is the optimizer. So the query optimization is the process that it's going to take your SQL, but it's a program. It's going to take your SQL, it's going to create an execution plan. When we're thinking the optimizer, we're always thinking, oh, this big program is going to create an optimal plan. That is false. The optimizer is going to try to get one optimal plan. But how do we define optimal? Well, it's going to be optimal in terms of cost. Usually, cost correlates to performance, but it's not mandatory. Is that clear? So the optimizer is going to optimize cost. If we provide to the CBO good input, that means the CBO, when it optimizes cost, that cost may be closer to your performance. Is that clear? Just think that way. The optimizer is quite complex, it's resource intensive, it will take some time to come with an optimal plan, not necessarily the best plan. So it's going to input some knowledge about your data. In most cases, it won't use dynamic sampling. So that means whatever the code-based optimizer generates as an execution plan is going to be based on what? It's going to be based on statistics, binds, access methods that we provide, parameters that we specify, but not in our data. So if the statistics are saying I have 3 rows, and in reality I have 3 million rows, well, the optimizer doesn't know that. The optimizer is thinking 3 rows. Is that clear? Just keep that in mind. How accurate it's going to be? Well, it all depends how good is the quality of the data that we present to the optimizer. If there is a correlation there. The optimizer has to balance these two, flexibility, stability. There is always this trick, trying to balance these two. There are many parameters, like hundreds of parameters. And on top of that, we're expecting the optimizer to be fast, less than 1 second. That is what we expect. Whenever we ask the optimizer to generate an execution plan, we're expecting to be fast. When you put everything together, guess what? In most cases, you will get a reasonable plan, but in some cases, your plan is going to be suboptimal. Does it bother you? If it doesn't affect your business, nobody cares. Now, every once in a while, you will get a suboptimal plan that bothers your system, that bothers your business. In that case, we need to do what? SQL tuning. Okay? Keep in mind, statistics are very important. I have said this several times, but they're extremely important. And when we're thinking statistics, keep in mind, it's not only schema of the statistics, we have all these other pieces. One of them that you really want to look in detail is the one here, extended stats. For SQL tuning, this is like magic, extended stats. They really help. But it requires some setup, it requires some understanding of extended stats, and it requires some implementation of extended stats. But it is very good for SQL tuning. So why do we get a suboptimal plan? I mean, why are we here? I mean, why are we taking this class on SQL tuning? Why do we get bad plans? There are many reasons. They go from statistics, they go to not to use the default parameters. I mean, you see a lot of people today trying to tune the application by tweaking CBO parameters. And this is sad because there is no need. I mean, you don't go by SQL tuning by just guessing, trying, trial and error. Tweak this one because I saw this one on this blog, or I saw this parameter in this other database, and I want to tweak this parameter, and hopefully it's going to fix my issue. It shouldn't be like this. It should be like you do a deep analysis, and once you understand the root cause, then you know what is the answer. It will have an example of this game in which, I mean, you have like this small ball, and it only has one hole, and you're trying to make this ball to fall through the hole, and you're trying to find that point where it goes through. Tuning, it looks like it is like this, but it shouldn't. It shouldn't be something that you're just guessing, I mean, what is going to happen. Reasons could be many, but that's why, I mean, we need to analyze and investigate the root cause, and that is not easy, finding the root cause. So, some heads up. I usually do tuning like in 2 steps. The first step is sanity checks. Why? Because doing some sanity checks could be very fast. For example, if I am expecting to use an index here, the first question is, do I have the index? It sounds simple, but sometimes the index is missing. Sometimes the index may be invalid. The index could be unusable, right? So start with some sanity checks. Let's say you're looking at this SQL statement that is taking a long time to execute, it's affecting your business, and you look into AWR, and you're finding that the same SQL has like 50 different execution plans in the history. Well, the fact that you have 50 execution plans, that means what? Plan stability. Okay, so your SQL in terms of execution plan is not stable. What are the main reasons to have unstable plans? We mentioned that yesterday. No, having binds together with histograms. Then, depending what you see on the sanity check, you say, you know what, I see too many plans. I am suspecting plan stability. I am suspecting binds. I am suspecting histograms. Is that clear? So you, just by taking a quick look, you start having some ideas what is the next move, the next step. Another one. Imagine you see on your execution plan, you see nested loops all the way up and down, and you see the actual number of rows is a large number. What is that telling you? If you look at the execution plan and you see the actual number of rows and it's a large number, and you see nested loop, nested loop, nested loop, index access, index access, index access, what is that telling you? And it's going to be very expensive, right? So the reason the CBO may create a plan like that is because the CBO is thinking that you will have only a few rows. So the CBO is making a mistake. I always say the CBO is like my mother-in-law. Once you make the first mistake, you are doomed. Okay? So that is the CBO. Once you make the first mistake in the execution plan, you are doomed. Everything else is going to be kind of incorrect. Okay? So the trick is finding where the CBO is making the first mistake. So when you see a lot of nested loops and you see large number of rows, that is a red flag. Stop there and see you say the CBO is making a mistake. Now my objective is find where the CBO is making the mistake. Go ahead.
The question. So the CBO doesn't look the exact data that is in the table, but it's just making use of the statistics that is available.
That is correct.
In the statistics, it says the table A, B. So the table A says only 3 rows, and the table B says it's millions. In fact, the table A has thousands of rows, right?
Uh-huh.
So when you look at the execution plan, the plan is also going to say the same 3 rows and million rows.
Yes.
So how do you understand I mean, why it should be the nested loop with a large number of rows?
Okay, when the execution plan is created, it's using estimated number of rows, which are coming from the statistics. The actual rows that you see on the execution plan, they are populated after the SQL is executed. So those 2 columns, estimated and actual, they are computed at different times. Estimated is when it creates the execution plan. Actual rows is when you actually execute the plan. It's too late to change the plan.
Okay, so that's only with the help of ticket proof or the SQLT plan I can give that.
Yeah, for SQL tuning, it's crucial that you get to see estimated number of rows, actual number of rows. Because you have to have the 2 sides of the story. If you only have one side of the story, you will have to be guessing the other one. And SQL tuning doesn't like guessing. Because guess what? Every time you have a guess on SQL tuning, there are dozens or maybe hundreds of possible reasons why you have that thing that you see or the thing that you don't see. So instead of guessing, just be sure that when you are actually engaged on a SQL tuning issue and you have to actually drill in and find what is the root cause, it's pretty much mandatory that you have estimated number of rows and actual number of rows. Otherwise, you have to be too good to say, oh, just by looking at this plan, I can say this plan is bad. I cannot do that. You have to have both. Okay? Sorry. There are some other heads-ups. Sometimes you look at the SQL, you need to understand the SQL. You cannot miss that part. I mean, your SQL is long, well, you have to invest more time, but you need to be able to understand the SQL. Okay? So when you read the SQL, sometimes just by reading the SQL, you find practices like this one here. Is that my voice? Good? Okay. Okay, so what do you see that is wrong here? Look at this predicate that we have. What is wrong with this predicate? Yeah, we have a decode, but what is wrong here? What are we telling the optimizer here? How do which table we join to which table? Or do we have a join or we don't have a join?
It's not a join.
Is it a join or is it not a join?
It looks like a filter. To the optimizer, it looks like a filter.
For optimizer like a filter?
No, it's a join based on the condition.
It's a conditional join, right?
It's a dynamic condition.
It's a dynamic, we can call this also dynamic join. We're saying, okay, if the value that we pass here matches this value, then this is the output of the decode. Therefore, my statement becomes P1C1 equals P1C1, which means no join. But if it matches this value here, then we join against this table.
Multiple plots.
Well, actually, the CBO can...
Actually, that could be a Cartesian or semi-Cartesian.
That is this for the... Imagine now that you are the optimizer. What do you do? I mean, do you join or you don't join? It's tough, right? So it's like flipping a coin. 50% of the cases you will take the right path, and 50% your execution plan is going to be poor. You throw a couple of statements like this inside the same SQL, and then the chances to get a good plan are minimum. Most probably you will get a suboptimal plan. The results are going to be fine, but the performance of that plan is going to be poor. So when you look at the SQL and you find like bad practices of coding, you say, you know what, it's going to be tough to the optimizer to create a good execution plan. It doesn't matter how you do it, it's going to be tough. So in some cases you have to step back and you have to fight with the developer to fix the code. Okay? So SQL tuning is not like always you take this path. I mean, you review high level, you do a lot of sanity checks, you review the SQL text, you look at the shape of the execution plan to see if that shape makes sense according to the volume of data that you're working on. And then you start saying, okay, let's say I look at many nested loops with, I am assuming here the CPU is making a mistake, so I'm trying to find where is the mistake. But if I see this one here, I say, you know what, this is bad coding, I have to go back and change the developer and question the developer why developing code like this and how we can make this better. How can we rewrite this SQL to perform better? Is that clear? So every case is a little bit different. Sometimes you see the statistics, and by looking at statistics, you are finding things that they don't seem to be right. For example, you have an index that has one column, and when you look at the number of distinct keys, it says 300. When you look at the number of distinct values for the same column, it says 3,000. There is a mismatch. One of the two is going to be wrong, and one of the two may be right. Is that clear? So some of these health checks that you can perform, they're going to tell you there is something fishy regarding the statistics. It doesn't necessarily mean that it's going to be the root cause. But if you see many things about the statistics that are fishy, that means most probably the bad statistics are going to be affecting your plan. Okay? Sometimes you see CBO parameters that over-tweak. You see, okay, I know that this parameter is going to favor the use of indexes, and they also have this parameter that is going to favor the use of full table scanning. Contradiction. So that means whoever is doing the set of the parameters, it may be a little bit lost, and is using some parameters they contradict. So it's like, I would question both parameters. Okay? Key, look at the estimated number of rows, multiply by the starts, and that should be similar to the actual rows. What does it mean? If you look at an execution plan like this one here, look at this column that says starts. Take this column that says estimated rows, multiply these two, and it should be similar to this column here, to the actual rows. Don't just look at this one here, because if you look at one compared to 352, you say, oh, this is a gap. No, it's not true. You need to multiply these two. Okay? Now, when I say number of starts times estimated rows should be similar to actual rows, this similar is kind of very flexible. It's like if it is 10 times more or 10 times less, it's perfectly fine. When it is like 100 times difference, then it's becoming a concern. If the gap is like 1,000 times difference, then it's a bigger concern. But whenever you have to compare these two, don't be very strict. Don't think it's going to be perfect. No, you will have some gaps. As long as the gap is small, you're fine. Now, when you start seeing some gaps, you need to review the execution plan according to the execution order. Why? Because that comment I made before, like my mother-in-law, find the first mistake. But the first mistake is not by reading the execution plan this way. It's by reading the execution plan according to the execution order. So that means we need to be able to determine, just by looking, quick look at this execution plan, what is the first operation to be executed? Here.
Table access customer.
Table access what?
Customer.
Customer. Yes, this one is the first operation in the execution plan. So you get used to read the execution plan according to the execution order. Okay? Because now if I review this one here, say, okay, I have 1 times 2,000 compared to 1,000. That's fine. I look at this one. 13,000 compared to 2,000. It's fine. It's close enough. 2,000, 13,000 is close enough. Okay? When you see the gap is like 100 times, then you begin to worry. But if it is less than 100 times, bigger or smaller, you are fine. Okay? If you are using SQLT, SQLT shows you something similar. This may be a different execution plan, but it doesn't matter. It shows you here estimated canality times starts compared to this one, and they compare it in this column. It's going to say, in this particular line, the CBO is doing an overestimate by a factor of 5. It's fine. When it becomes like more than 10, it's a little bit of a concern. It becomes orange. When it is more than 100, then it becomes red. Is that clear? So in SQLT, what I do, I check this column. If everything is black, it's fine. But if I see like red, then I look in there. And I do that by looking at this column. What is this column? Execution order. So in this one, this is execution order 1, 2, 3, 4, 5, and it goes on. So I can very easily read the execution plan by looking at this column, which I don't have here. Is that clear? So this column here, that was enhancement request number 1 for SQLT, like 10 years ago, or more than that, to show the execution plan, the execution order. And I asked this enhancement to be placed on the ticket roll. It is still pending. In many of the things that you see on SQLT, I open an enhancement request to say, let's improve the product, let's put this on ticket roll. They are still pending. They haven't been closed, but they are still pending. Okay, so some challenges that we may have on SQL tuning. Well, SQL tuning, we have the following challenges. Dependencies. First one, dependencies. In order to, an execution plan is a function of what? Parameters, statistics, binds, access methods, right? And many other things. For example, in my SQL contains a view. Well, I also have the dependencies on the object behind the view, right? If I have a function, then I have a dependency on whatever SQL I execute behind the function. Is that clear? The amount of dependencies that my execution plan has is huge. Way too many dependencies. I mentioned here some. Now, some of those dependencies, they are static, meaning they don't change over time, but some of the dependencies, they change over time. For example, statistics, they change all the time, right? Binds, they change all the time. Parameters, hopefully, they don't change all the time, but they may change. The same happens with objects like views and indices that we may create, we may drop. It's like a moving target. If you're trying to understand the execution plan that you have right now, it is enough if you find all the dependencies that you have right now. But if you're trying to see, okay, this SQL was performing fine last week, but today it's broken. You need to understand all these dependencies that you had last week and the same dependencies that you have today. So this is like an extra dimension that you have, which is time. Look at all these dependencies today, and also look at all the dependencies and how they have been changing over time. So that means there is a lot of information that we have. And this is like a catch-22. In order to do some SQL tuning, you have to be an expert on SQL tuning. Well, how do you become an expert on SQL tuning if you never do SQL tuning? Is that clear? So it's very easy to get lost. It's like, imagine you are a DBA working on this company and you are expecting to fix this SQL that suddenly is taking a long time. And there is a lot of pressure to provide some results. If you don't do SQL tuning often, it's like, I don't know where to start. I don't even know what is that I need to look. Is that clear? Why? Because there are so many pieces here. So how do we approach SQL tuning? It was quite often that we were engaged on issues like they will come like this. They will say, I mean, my customer will say, we're having this performance issue since this morning. Everything was working fine yesterday, and suddenly this transaction is not finishing. This SQL is hanging. Then I will say, okay, what have you changed in your system? And guess what is the standard answer? Nothing. So we haven't changed anything. Now in those days, I didn't know anything about SQL tuning. It was black magic. So I would think, well, if they didn't change anything and this SQL is misbehaving, maybe we don't do anything and it will go away. The issue will go away. Right? So that was my technique, right? And I was quite surprised that sometimes it worked. Sometimes I wouldn't do anything, they wouldn't do anything, and they would just close the server request. So that means the issue was fixed by itself. Maybe, I don't know. That was a long time ago. Another way to do SQL tuning is to have like a third-party consultant. And some of you guys are consultants, right? Who's consultant here, doing consultant work? One person, 2, 3, 4. If as an Oracle site, if you get engaged, I mean, you get to engage a third-party consultant and you have good results, a good consultant is like a good mechanic. Keep him for life. Okay? Why? Because you don't get to find a lot of good people on the field. I mean, you get to find a lot of people, but you don't get to find a lot of good people. So whenever you come across someone that is good on your SQL tuning and is helping your environment, my suggestion is keep the guy for life. because the SQL tuning is quite hard. It's going to consume a lot of resources for your site to get to train someone to be good at SQL tuning. And keep in mind, you don't do SQL tuning every day. So anyway, that's just a point here. Another one is to actually get some training, like this class or any other class that enhance your SQL tuning skills. What about this one here? Silver bullets. Everybody wants silver bullets, right? Yes? No? Okay. So you may want to see for some, to look for some silver bullets. I will talk about this one in a moment. Maybe a combination of the above. But what I think, the way we should approach SQL tuning is consider what are the best practices, which are basically just consider a methodology that works. This is what I have to say about silver bullets. When someone is asking me, give me some silver bullets for SQL tuning, that is my answer. I cannot give you anything. I don't believe in silver bullets for SQL tuning. Nevertheless, every once in a while you will find some consultants are going to offer silver bullets. Just be careful, because when you are trying to apply this fix helped this customer 5 years ago and my issue went away, it doesn't mean that you apply the same technique and you will get the same result. It doesn't mean that. So it's very common that you are trying to apply a silver bullet and the issue is going to bite. Just keep that in mind, okay? Any questions, comments? No? Okay, so when I say best practices, really what I mean is kind of a systematic approach. How do we approach a SQL tuning issue? Well, I will say it is like a health check or a checklist that we do. We validate what are the requirements for the business. If I'm working with this transaction, like let's say booking an order, and booking an order should be a matter of a couple of seconds. Well, the business requirement says I need to have that in a couple of seconds. Then, if that is not the case, let's say my transaction is taking 10 seconds instead of 2 seconds. Well, you need to find the bad SQL. Because if your transaction requires a couple of hundred of SQL statements, not everything could be bad. You are trying to find from all these SQL statements which ones are the ones that require more attention. So how do we do that? Well, usually we get traces, like we saw this morning. We generate a trace file. From the trace file, we look at the top SQL. Any SQL that is taking most of the resources. Then the next one, collect comprehensive diagnosis information. This one is quite tricky because unless you know how to do SQL tuning, you are not clear what is that you need to collect. And this is where SQLT is going to help. SQLT helps to collect everything that is needed for SQL tuning, even though you may not know what is that you need. Is that clear? So you have a performance issue, you have this SQL, you run SQLT for this one SQL, and it collects everything that someone that knows how to do SQL tuning can use. It could be yourself, it could be your friend, it could be the third-party consultant, it could be Oracle support. It doesn't matter. What is important here is that we collect everything that we need. Is that clear? And then we perform some health checks or sanity checks. After we went through this one and we do all our sanity checks, everything looks fine. I cannot find possible reasons. I have to sit down and invest time here. Analysis. In my experience, and Abel may have a different experience, in my experience, to analyze a SQL performing poorly is a matter of the least a couple of hours, the most maybe a couple of days, or it will take some time. Abel, in your opinion, how much time, if I give you a SQL tuning issue from scratch, how much time do you need to invest in order to find a root cause?
Thank you for putting me on the spot. Okay. I'm going to answer with an analogy. In support, we do things 3 ways. We do fast, good, and cheap. Since we're already paid, we're already cheap. So from the customer perspective, it's already paid for, very cheap. So either I do it good or I do it fast. So either if I'm going to do it only good, definitely not fast. Okay, so really there is no timing for. I have spent one issue 3 weeks. That's the longest that I've been working a performance issue in which I had to review absolutely everything that I could think of to finally find all the causes of the query being slow. 3 weeks. And of course there was not one issue, there were many. Sometimes just a quick glance can get you some tips there, but there is no good time for it to do any kind of.
But let me ask it a different way. How many SQL tuning issues do you see in a month?
That's even worse. I get like 10 pings a day, 10, 15 pings for people a day, that I own about 3, so like 90 personally.
90 issues, 90 SQL tuning issues per month.
Yes.
Okay.
But if you count all the pings that I get, I don't know. I never take the counting.
Okay, I mean, issues that you work around 90 issues per month that has something to do with SQL tuning.
I would say take 30.
Okay. So, thank you. My number is around 30. I work like on 30 SQL tuning issues per month. So that means, and this is not the only thing I do. I mean, I do different things. So SQL tuning is part of my daily life. Right? Every day I get engaged in at least one SQL tuning issue. And I will say that in average it will take something between a couple of hours, and in some cases, like worst cases, it may take a few days. I never gone like weeks with a SQL tuning issue, but a couple of days is possible. So when I say here you have to invest some time, it really means nothing else. You have to work on your issue one day, maybe a couple of days, to find what is the root cause. Just keep that in mind. It's not easy. SQL tuning is not easy. It takes some time. So in order to do that, we apply this method. You guys remember this from high school, scientific method? Yes? Kind of? Still vague? Okay. So we apply this method, and then we implement whatever changes we require. So what is this scientific method? This is a quick review. This is a description of what is scientific method. I see the scientific method for SQL tuning like 4 steps. We formulate some hypotheses, so that after we do initial review, we say, okay, I'm thinking it is, I don't know, history, or it is bad. Once you have some hypothesis, you are trying to prove you wrong. But one step that we do here, we estimate the gain. We say, okay, assuming I fix this issue that I see on this execution plan, my performance should go from this long to this long. That is what you are assuming. That is your target. In some cases, we have to create a test case. Because if you have this idea, you say, if I were to change the plan this way, I may get better performance. Well, you have to create a test case. Regardless if you need a test case or you can test on the same environment where the issue happened, you have to test your hypothesis. You may need to reformulate hypothesis, and then you keep looking here until you find your answer. Sometimes it's only one cycle, sometimes you go on and on and on, trying different things. Okay? This is another way to see scientific method, but it's the same. I mean, we cannot avoid this. When it comes to SQL tuning, once you have some clues, you have some ideas, you just don't say, oh, this is the answer. No. What you say is, it looks like this is your issue. It looks like if you do ABC, this should be the result. Now we have to try it. Is that clear? That's how we approach SQL tuning. Now, since SQL tuning is hard in the sense that it's quite complex, what are the things that we can automate? Because there's some pieces we can automate. Well, this is just a small list of things that we can actually automate with some sort of tool. The gathering, for example, collecting all the execution plans, collecting all these diagnostic details, meaning metrics, metadata, dependencies, current metadata, historical metadata, everything can be automated. We just need to have the scripts. to collect everything. Is that clear? To extract a test case. That can be also automated. To provide health checks can be automated. Everything that you see here can be automated. And that's what we do. I mean, I will get there. That's what we do here with SQLTXPLAIN. Now, when it comes to using tools, if you don't do SQL tuning often, you will say, okay, SQL tuning I understand is complex, I don't do this quite often, where do I start? Well, I mentioned before that we usually start here with SQL trace, SQL program. What else do we have available? We have the 10053, right? Stretching the optimizer, so we get to understand how the CBO works internally. We may use the explain plan 4 command, we may use DBMS explain API, we have the auto trace, we have method R, we have trace analyzer, we have ASH. In ASH, we have a lot of information. We can do some data mining on ASH to understand better our execution of our SQL. We have that. We have active monitor report. We have DBMS SQL diagnostics, tooling advisor, and of course, I mean, I say of course because that's the topic here, we have SQLTXPLAIN and SQL Health Check. Everything that you see here are basically tools that you may want to use when you are dealing with a SQL tuning issue. Now let me talk about this one here because you know pretty much all these tools, right? Do you have any questions about any of these pieces here? No? What is this one here? When I say the tune advisor, who uses the tune advisor? Some people. Okay, most of you guys. And what is your experience with the tune advisor? It's very bad. In which sense?
It always comes back. It always comes back and tells me that there is nothing to advise.
Okay, it's come back. In which release are you at of the database? 11G? From 10G to 11G it has been getting better, but it's not perfect. And
yeah, I did use on multiple occasions where sometimes we see the long-line sequence. We ask the tuning advisor to give a different plan. It comes back with a better plan, and we say that go and implement the plan. It went and implement the plan. The same query was, for some reason, it's fantastic.
So you have good experience, you have bad experience. Who has good experience with the tuning advisor? 1, 2, 3, 4. Okay. Who has bad experience with tuning advisor? Okay. So we have like mixed experience here, but I would say most people will say it's overstated. I mean, say SQL tuning advisor is not as good as I was expecting to be, right? That's what it seems to be here. But still, I mean, tuning advisor may give you some clues. For example, if I see the tuning advisor is suggesting to implement this profile, I don't implement the profile, but I look at the content of the profile. I look at the hints inside the profile. And if I'm looking at the hints inside the profile, I see these huge scaling factors. Those scaling factors are basically saying estimated number of rows and actual number of rows is way off. So that means the CBO made a mistake. Just by looking at those numbers, that gives me some ideas, I mean, where the CBO is making a mistake. Okay, just keep that in mind. Or if it says, oh, you rather create this index, you may say, oh, I should have this index. Why is this index missing? So in that sense, the tune advisor can give you some hints where to go next. Okay? So now let's talk about SQLTXPLAIN. And I will start with a quick introduction here. So what is this tool? What is this? Well, it's a tool that is available through my Oracle support. That is the node number. And you have the latest version. There is a latest version like once per month. So it has an upgrade like once per month. So it's an add-on tool. It's available on 10G, 11G, it's the same source. But if you need like something for 9.9 or Oracle 8, we still have those versions and they're available. It works on Linux, Unix, and Windows. It can work on a single instance. It's rack aware, it's Exadata aware. It's easy to install and use, it's not intrusive. It doesn't try to consume all your resources. No, it's just one more program that when you run SQLT, it's going to consume some resources during some short period of time. And the one that everybody likes is this one here. It's free. In these days, Oracle doesn't give you a lot of things for free. Okay? So I know that. This one is still free, and I hope it's going to continue like a free tool. It's not in my hands, it's not my code. So far, I mean, we can offer this free, download, and use. This is one of the tools that when I'm a consultant, Oracle consultant, external consultant, doesn't matter. When we start using this tool at the Oracle site, and our customers start looking at the output, is naturally adopted. They say, okay, we like the tool. Can we use this tool enterprise? The answer is yes, you can use the tool enterprise. Why? The whole idea of the tool is to help each other. I mean, since the tool basically collects everything that we need for SQL tuning, it's a win-win. Let me try to explain. Let's say you are working, you're either as a third-party consultant or you're working as a DBA for this Oracle site. I mean, meaning Oracle user site, let's call it that way. You have a performance issue, you have a SQL that is misbehaving. You capture everything out of the SQL with SQLT. If you don't practice SQL tuning quite often, just by looking at the output, it's like a jigsaw puzzle. You start putting things together. You say, I can see adaptive cross-site sharing is here, I can see the execution plan, I can see the statistics, I can see the health checks. When you start looking at everything there are some pieces that you say, oh, now I understand this extra piece. Every once in a while I get as a feedback people saying, I have learned SQL tuning by looking at the output of SQLT, which wasn't the idea, but it's kind of very nice to learn that people are learning SQL tuning just by looking at the output. That is a win. Another win is when it happens that you are stuck on the SQL tuning issue, that you say, when I get stuck on a SQL tuning issue, I go to Able. Okay, that is my to-go person. Everybody has a to-go person. And who is your to-go person when you have a SQL tuning issue?
You are.
I am. So, yeah, sometimes I get stuck on an issue that I cannot handle the issue, I can understand the issue, I go to Able and he can explain the issue to me. Sometimes it's the other way around. Why? Because we have different experience, different way to troubleshoot that with issues, so we learn from each other. So everybody has like a to-go person. Sometimes the to-go person is Oracle. Sometimes you will say, you know what, I'm stuck here, I need to ask Oracle to help me with this issue. If you have all these files collected, that's a huge step. You are helping yourself and you're also helping Oracle. You want to
it's very common in support. I mean, that we have what they call it, let me engage the guru about it. I mean, it is true that, I mean, Carlos and I do this more often and we know more, but there's always somebody else in Oracle that knows more than you do. We rely a lot in each other to solve an issue because we tend to have a different approach to query tuning. And so we build a network of people, and when we start to devise something, we engage the other person, start to discuss it, and sometimes the solution comes along. But it's always paramount that we have all the information there available. I get, in the position that I'm in support, I constantly get calls from other people asking me, I have this issue, I have that issue. The first thing that I ask them is, do you have a SQLT with it? Or do you have it? If they don't have it, I tell them, get it and then we talk. Because whatever I can tell them, or we can discuss in a conversation, or whatever, is pure speculation. Until we have facts, which is what the SQLT captures. Once you have all the available facts, then you can start to work in practice. Then you can start that scientific method. Otherwise, it's astrology, I guess. I mean, when the moon was blue, you got a good execution pattern.
Perfect. Thank you. Thank you. Questions? Comments? Okay, so what are the benefits? The benefits are many. I have a list here. If I summarize the benefits, I would say the one here. At the end, the benefit of SQLT is that it helps to expedite your SQL tuning. It won't do the issue to go away. It has no magic that is going to say, oh, pass your issue through SQLT and immediately solve. No, it doesn't work like that. It just makes this possible, to make the tuning process to be faster. Did I mention this one here? It's free. It's free. So you just keep that in mind. How does it work? Well, there are 5 core methods to analyze one SQL statement. At the beginning, there was only one method. The method was called explain. So that's why the name is SQLT explain at the beginning. But now we have 5 methods. all of those methods, somehow, they will input one SQL statement, and they output a zip file that contains many files inside. Among other things, everything that you see here is included in SQLT. So that means SQLT, it collects from here, from here, from here, put everything together, packages everything, and give you one place with everything that you need. It includes test case. Actually, it includes two test cases, one that is coming from the product and one that is coming from SQLT. So it gives you two test cases ready to be implemented. And it has some other modules and some other utilities. Well, let's start with the 5 core methods. Now, there is here an issue I need to mention. When you install SQLT, it creates a schema. Actually, it creates 2 schemas, and it creates several objects in these 2 schemas. So it has a couple of schemas. So that means it modifies the database. It creates schemas on the database. That's something you need to be aware of. So how do we install SQLT? Usually we download this file, SQLT zip, from this node. When I say usually, because here I gave you the file, but if you don't have the file, you just download the file from this node, unzip into the server, and execute SQLCreate. About installation parameters, we do not input the parameters this way. I wish we could, right? We input the parameters command line. So it's like trace analyzer. It's going to ask some parameters, we input the parameters, and the tool is installed. The first parameter is an optional connect identifier. I usually don't talk about this one. I just say in most cases, it just enter nothing, just skip this one. But I'm going to mention this because someone here mentioned that, gave me the clue that you may need this one here. Let's say I cannot access the database server directly. Let's say I am an application developer. I'm given access to the database server, but only to a DNS alias, right? To a connect identifier. So can I install SQLT over there? The answer is yes, but I need to learn how to do that. And the key is this one here. So I connect to my database or to my SQL process that I can access. And if from here I can access the other database to the connect identifier, I pass this connect identifier. So I can actually, through the connect identifier, I can install the tool on the database. Is that clear? So there is a method to do that. So I provide the password for SQLT, default table space, temporary table space, the main application user. SQLT, when we have someone that is running SQLT, it requires some grants, minimum grants, but we require some grants. Like for example, I need to be able to read the data dictionary. So those grants are assigned to the SQLT user role. So for someone to run SQLT, they have to have the SQLT user role granted. Is that clear? So that is why whenever we install SQLT or whenever we install Trace Analyzer, it's going to say who is going to be using this. So we provide this grant, and if your site is very sensitive about this grant, you can revoke this attribute once you are done. Is that clear? So that's why we have those grants. And the last question that we have is, what is the Oracle pack license that we have? If you have the tuning pack, you say T. If you have diagnostics pack, you say D. If you have none, you say N. Depending how you answer this question, that would restrict the output of SQLT. If you say, go ahead.
But if you have both the tuning and diagnostics, so you put TD?
No, just put T. T. Yeah, because diagnostics is included inside T, inside tuning pack. So you have tuning pack, put T. If you don't have tuning pack and you have diagnostics, then put D. If you have none, then enter N. Hmm? Yes, you have both, then just put the T. Tuning. Tuning is going to give you everything. Diagnostics is going to restrict the output, and N is going to restrict the output even more. Why? For example, diagnostics is required to expose anything that has to do with AWR. Okay? So if you don't have diagnostics, I cannot access data from AWR. So SQLT, depending how you answer this, is the scope of the output. Any questions there? No? Okay. So once we install, how do we know the installation succeed? Just look at this last line. Okay? If you don't see this one here, guess what? Something was wrong. Let me do the installation so you can see actually how we install SQLT. Very similar to how I installed a trace analyzer. So I'm going to go here to Tools, and on trace analyzer I copy this SQL+. I'm going to do the same here for SQLT. So the first step, I'm going to extract SQLT is here, and now I have my SQL+ alias, so I can open SQL+ from here. I just click this one, which basically the only thing that I'm doing, I will open SQL+ from this directory. And I am connected as is to my local database. So the only thing I do is install SQL create. When I do that, it's going to say optional connect identifier. In most cases, you enter nothing, just hit enter. What is the password I want for SQLTXPLAIN? It's case sensitive, enter my password. Default table space, in this case, it's coming with the default of users, which is this one here. Basically what it means is, when I see this one, it means I already have SQLTXPLAIN. This one to try to do an upgrade. SQLTXPLAIN, when you install SQLTXPLAIN and you already have SQLTXPLAIN, it's always trying to do an upgrade. Trace Analyzer is different. Trace Analyzer is uninstall and reinstall automatically. SQLT is always thinking that it's doing an upgrade. So it's doing an upgrade, say, yeah, I will take users, which is what I had before, and I will take temp, which is what I had before. Otherwise, I will have to cut and paste a valid table space name. Now it's saying, who is going to be the main application user? If I say here, this user, the only thing that it's going to do is going to say, grant SQLT user role to this user. That is what is happening. The last question is, if you have license for diagnostic and tuning, you enter T. If you have the license for diagnostics only, then you enter T, otherwise you type in N. So in this case, I type in T, tuning, everything, and it's going to take here a moment to install. Look at the following here. It's saying something about Trace Analyzer. Well, Trace Analyzer can be installed standalone, like we did this morning, or whenever we install SQLT, it also installs Trace Analyzer inside SQLT. So in this case, I can have both. I mean, I can have Trace Analyzer by itself, or I can have Trace Analyzer inside SQLT. So right now what it did, it compiled Trace Analyzer inside SQLT.
Inside the SQLT schema?
Inside SQLT schema. Yes. So I can go ahead and remove Trace Analyzer, and it doesn't affect SQLT, because SQLT, Trace Analyzer is going to be, right now in my system, is going to be installed in two places, by itself and inside SQLT.
So both are installed automatically with this?
Yeah, when you install SQLT, it installs automatically Trace Analyzer inside SQLT. Yeah, but some customers, they may want to install Analyzer by itself and not SQLT. So right now it's compiling SQLT.
So it's creating two schemas now?
SQLT has two schemas, Trace Analyzer has two schemas. Yes. Every time it's doing an automatic upgrade, keeping the repository. So you have anything on the SQLT repository, that one remains there. So this one finished. Again, how do I know the installation was successful? I just look at this line, and it says it was successful. So everything is fine. During that process, it created several log files. So if for any reason it disconnects, one of these log files will have some errors. Right now, since everything went fine and it says it completed successfully, I don't need the log files. I can remove these log files. So if for any reason at some point you try to install SQLT and it disconnects, look at those log files. If you cannot make any sense of the error are usually like table space doesn't exist. or it runs out of space on the table space. Those are typical errors. But if you get one of those errors that is not that trivial, just shoot me an email and I will let you know what